discuss the methods. Okay. Next, already some problems are over. Another two problems to discuss. Next, we'll start partial fraction. Okay. Yesterday one problem I'm telling one minus of rationalize the denominator. 1 minus root of x plus 1 divided by 1 plus root of x plus 1. Rationalize it. Simplify the fraction whose denominator is a quadratic, binomial quadratic surd. Okay, multiply the numerator and denominator of the conjugate of denominator. Okay, 1 minus root of x plus 1 divided by 1 plus root of x plus 1 into multiply and divide 1 plus 1 minus conjugate of denominator divided by 1 minus root of x plus 1. Okay, into 1 minus root of x plus 1 into 1 minus root of x plus 1. A minus b into a minus b whole square. 1 minus root of x plus 1 whole square. Okay, R each one multiply a minus b into a minus b, a 1 into 1 plus 1 minus root of x plus 1 into 1 minus plus root of x plus 1 into root of x plus 1. In denominator is a p form a plus b into a minus b, a square minus b square. Root of x plus 1 whole square. Okay. A minus b whole square, a square plus b square x plus 1. Root of x plus 1 whole square. The square root of. You know this square root of x square is equal to x. This one also same x plus 1. Okay, minus 2ab. A is 1, b is root of x plus 1. Okay, whole divided by 1 minus root of x plus 1 square is x plus 1. Okay, now a square plus b square minus 2ab. 1 plus 1 2 plus x plus 2 into minus 2 into root of x plus 1. Whole. Next question, last one. Root 1 by root of 3x plus 2 minus root of x plus 2. Okay, rationalizing the denominator. Same one as first given as it is 3x plus 2 minus root of x plus 2. Okay, into root of 3x plus 2 minus root of x plus 2, conjugate of the denominator, divide by root of 3x plus 2 minus root of x plus 2. 1 into root of 3x plus 2 minus root of x plus 2 divided by a minus b into this one is plus conjugate of the denominator. Okay, a plus b into a minus b, root of 3x plus 2 whole square minus root of x plus 2 whole square. Root of 3x plus 2 plus root of x plus 2 whole divided by root x square is x, means 3x plus 2 minus root x square is x, root of x plus 2 whole square is x plus 2. Root of 3x plus 2 plus root of x plus 2 whole divided by, observe that 2 minus is multiplied, minus 2 plus 2 cancel, x minus x is 2x. This is the answer. Over such, next can go for partial fraction chapter. Next new chapter, partial fraction. Partial fractions. Partial fractions. Okay. Partial fraction means to decompose a fraction x to the power n minus 1 plus a2 x to the power n minus 2 plus and so on an, or an into x to the power 0, or an into x to the power 0. X to the power 0 value is 1. 1 into an. Okay, the polynomials and expression of the form this one, very important partial fraction. Okay, but this is not in syllabus in first year, but we have to use this chapter in second year syllabus integration. Okay, f of x is a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus and so on a to the power n, where n is a positive integer. N is a positive integer and a0, a1, a2 and so on an are real numbers. Are real numbers. Are real numbers. Is called a polynomial in x. Is called the polynomial in x. Polynomial in x. Is called a polynomial in x. Okay, it is of degree n. It is of degree what? N. It is of degree n. If a0 is not equal to 0, okay, it is of degree what? N. If a0 is not equal to 0, a0 is not equal to 0. The polynomial of degree 0, the polynomial of degree 0 is called a constant polynomial. Is called a constant polynomial. A polynomial of degree 0 is called the constant polynomial. Constant polynomial. Constant polynomial. Constant polynomial. Constant polynomial means what? A polynomial of degree 0 is called constant polynomial. Okay, that is 5 is equal to 5 into x to the power 0. 5 is equal to 5 into x to the power 0. Whose degree is 0, then it is called constant polynomial. Whose degree is 0, then it is called as constant polynomial. Okay, 7 is equal to 7 into x to the power 0. Okay, and a0, a1, a2, a3 and so on an all 0. All 0. Are all 0. That is called as 0 polynomial. Okay, a0 0 polynomial. That is f of x is equal to 0. f of x equal to 0 means what? 0 polynomial. Okay, in x. Next is, for example, for example, 2x cube minus 3x square plus 5x plus 3 equal to 0 are as it is, this function. And next is 7x to the power 5 plus 6x to the power 3. Next is 3x square minus 5x plus 7. Okay, the functions. Okay, this one. The polynomial of degrees are what? Both 3 and third degree. So 3 and 5. Okay, and these two functions, these are degrees are what? 3 and 5. 3 and 5. The polynomial of third degree and fifth degrees. Okay, of the given polynomial. The polynomial degree is what? Third and fifth degrees of the given polynomial equations. Okay. Next, some definitions are there. Rational function. Rational function. Rational function. Rational function. Rational function. If f of x by g of x, if f of x sin g of x are two polynomials in x, are two polynomials in x, and g of x is not equal to 0 if f of x and g of x are two polynomials in x and g of x is not equal to 0, then f of x divided by g of x is called the rational function. 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 Is of the form of rational function, numerator divided by denominator, numerator and denominator. F of x by g of x. Okay. Next is improper fraction. Next definition, proper fraction. Proper fraction. A rational function, f of x by g of x, f of x by g of x, a rational function f of x by g of x, the rational function f of x by g of x, comma, g of x is not equal to 0. G of x is not equal to 0. Next is the rational function f of x by g of x. In this already mentioned, f g of x is not equal to 0. Okay, is said to be proper fraction. Is said to be proper fraction. Is said to be proper fraction. A rational function f of x by g of x is said to be proper fraction. Next is, then if the degree of the degree of f of x is less than less than the degree of g of x. This is proper fraction. Okay, a rational function f of x by g of x is said to be proper fraction when if the degree of f of x is less than the degree of g of x. Okay. For example, x plus 1 divided by x minus 2 into x minus 3. This means x square, x into x square, x into minus 3 minus 3x minus 2x minus 5x plus 6. Okay, x plus 1 divided by what? X square minus 5x plus 6. This is what f of x is less than the degree of f of x is less than the degree of g of x. This is f of x, this is g of x. Okay, this is 1 divided x square plus 1 divided by x cube minus 1. Okay, f of x degree is what? 2. G of x degree is what? 3. Okay, this one degree 2, this one degree 3. Next is 2 divided by x plus 1. Okay, f of x degree is what? 0. G of x degree is what? 1. These are improper function. Proper fraction. This is what? Proper fraction. Okay. Next is improper fraction. Improper fraction. Improper fraction. A rational function f of x by g of x is said to be proper fraction. Is said to be improper fraction if the degree of f of x is greater than or equal to the degree of g of x. Okay, the degree of f of x is greater than or equal to the degree of g of x. Okay, this means f of x is greater than or equal to g of x. Okay, for example, x plus 1. Okay, f of x is greater than or equal to g of x. X square plus 1 divided by x minus 1 into x minus 2. Both of degree same. X into x square. Okay, this means what? X square minus 2x minus x minus 3x plus 2. Okay, x square plus 1 divided by both of degree is what? 2. This is what? Improper fraction. Next term, f of x is now x cube plus 1 divided by same x square plus minus 5x plus 6. Okay, this one, or 2x square plus x plus 3 divided by 2x cube, x 2x square minus 3x plus is of degree 3 is of degree 2. Okay, this type of functions are improper fractions. Okay. Next is any improper fraction, any improper fraction can be expressed as a sum of a polynomial and proper fraction. This means improper fraction is given. First you have to convert to proper fraction. Then solve. Okay. Then solve the given function. Okay. First you have to reduce the proper fraction. When given fraction is improper fraction you get, first you have to convert to proper fraction. This means any improper fraction can be expressed as a sum of a polynomial, and proper fraction by using division method. Now, the condition is that numerator below denominator, the f of x by g of x, quotient plus remainder divided by denominator. Okay, using first by division method, long division method. Okay, for example 3x square minus 4x plus 5 divided by x minus 1. This is what improper fraction. F of x is what? Greater than g of x. F of x is greater than g of x. First, we have to solve x by actual by division method. X minus 1, 3x square minus 4x plus 1. Okay. Into 3x. This one is cancelled. X minus 1 into 3x. 3x into x, 3x square. Next is 3x into minus 1, minus 3x. Minus, this one is plus. 3x square changes the sign. This is plus, and changes minus, this is minus, plus. 3x minus 4x, minus x, plus 5. Into 1, already minus x is there, plus 1. Okay. 1 into x minus 1, x minus 1. Okay. Into minus 1, okay, minus x, minus into minus, plus 1. 1 into 1, minus 1. Okay, changes sign. Plus, minus into minus, plus 1. Changes sign, plus, this one is minus. Cancel 5 minus 1 is 4. Okay. Therefore, this is f of x by g of x, numerator denominator. Quotient plus. Quotient is what? 3x minus 1 plus remainder is 4. 4 divided by denominator is x minus 1. This is of what? This is proper fraction. F of x is less than g of x. F of x degree is 0, g of x degree is 1. Okay, solving this one. Okay, given function is proper fraction, the improper fraction. First we have to convert proper fraction using by division method. Okay, solve this using this one. Quotient plus remainder divided by denominator. After that, solve the equation. This one. Next I will tell you solve the equations. Some rules are there. Next is resolve into partial fraction. Resolve into partial fractions. Okay, resolve into partial fractions. Take any proper fractions f of x by g of x. Take any what? Proper fraction f of x by g of x. The denominator of g of x can be factorized in terms of the factors of the form ax plus b. The denominator can be factorized in terms of the factors, okay, of g of x of the denominator. For g of x of the form ax plus b, this is what linear, and quadratic form ax square plus bx plus c. Okay, this is irreducible quadratic. Okay, next is a proper fraction can be written as expressed as a sum of polynomials of the partial fractions. Okay, according to some rules. According to the following rules. Rule 1 first. Rule 1. Okay. Rule 1. To each non-repeated linear factor, ax plus b, non-repeated only once, linear factor ax plus b of g of x. There corresponds the partial fraction of the form a divided by ax plus b. there corresponds the partial fraction of the form a divided by ax plus b, where a is constant, not equal to 0. Okay, corresponds a partial fraction of the form a divided by x plus b, where a is constant, not equal to 0. Not equal to 0. This is first one. For example, x divided by or x plus 1 divided by only 2 divided by x plus 2 is there. We have to take a divided by x plus 2 only. This is what? Proper fraction. F of x degree is 0, g of x degree is 1. A divided by x plus 2. Okay. Second one, rule second. To each repeated linear factor plus a2 divided by x plus b, okay, a3 divided by x, this is square, next a3 divided by x plus b whole cube plus and so on a divided by x plus b whole to the power n, where a1, a2, a3, an are constants. a1, a2, a3, an are constants, where a1, a2, a3 and so on an are constants. Are not both 0. Are not equal to 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 0. Okay. Are not equal to 0. Are constant. A is not equal to 0. This means n is not equal to 0. Next, third one, only 4 rules are there. Rule 3. Rule 3. To each non-repeated, to each non-repeated irreducible quadratic equation, irreducible quadratic factor, irreducible quadratic factor, x square plus bx plus c, or quadratic factor x square plus bx plus c of g of x. There corresponds a partial fraction of the form x plus b divided by x square plus bx plus, where a and b are not constant. A and b are constants. A and b are constant. A and b not equal to 0. A and b are not equal to 0. A and b are not equal to 0. Next, fourth one. Okay, A and B are constants and not both 0. Not both 0. not both 0. Both A and B are not both 0. Next, last one, rule 3. Rule 3. Rule 4. Last rule. To each repeated quadratic factor ax square plus bx plus c whole to the power n of g of x. They corresponds n partial fractions of the form a1x plus b1 divided by ax square plus bx plus c. Next, a2x plus b2 divided by ax square plus bx plus c whole square, and so on. Ax plus b1 bn divided by ax square plus bx plus c whole to the power n. Same a1, a2, a3, a1, a2, b1, b2, and so on. A and bn are constants, are not equal to 0. Okay, where a1 b1, next a2 b2, and so on. an bn are constants, and an bn are not both 0. Okay, these are the rules resolve into partial fraction. Okay, take any proper fraction. Okay, all are denominators of the form ax plus b, linear factor and quadratic factor. Okay, second is of the form. For example, second one. For example, second is, for example, x plus 1 divided by x minus 1 into x minus 2. Okay, a1 or a divided by, this is x minus 1 divided by x plus 1 divided by x minus 1 whole square. First, you have to write that a divided by x minus 1, a1 divided by ax plus b. Next, plus a2 or b we have to take b divided by x minus 1. To each repeated linear factor is what? A plus ax plus b whole square of g of x. Then corresponds to partial fraction of the form a1 divided by x plus b plus a2 divided by x plus b whole square. Okay, this is b divided by x minus 1 whole square. Third rule is x minus 2 divided by x square minus 3x plus 2. This is a quadratic form. Now, ax plus b divided by ax plus b divided by x square minus 3x plus 2. So, third one, to non-repeated x square, only one term is there. 2 or 3 terms, then ax plus b over x plus b. Okay, or a1x plus b1, a2x plus b2. Square terms or third terms, this is the form. Okay. Next is one table telling that form of the rational function. Form of the rational function. Okay. Tomorrow I am telling that. Thank you.